Hi, this is Mike Power, President and CEO of Silver Range Resources, and this is an update on our Bellehelen project. First, quick word from our lawyers. And before starting, I'd like to thank the following companies and their staff who've helped bring us this far. Bellehelen is located about 50 miles east of Tonopah on Highway 6, accessible via the Golden Arrow Road. You'll need a 4x4 to get around on the property, though. As of January 2022, we had 71 federal claims comprising the project in two blocks. The bulk of them are BH and KW claims, and they cover most of the known mineral showings in the Bellehelen district. The claims abut a wilderness study area, which affects road access for exploration, but not eventual development, where you'd find an ore deposit in the wilderness study area. Bellehelen's a silver camp, was discovered in 1904, had its best days between 1909 and 1911 when about 500 people lived at the small town of Bellehelen at the mouth of the canyon. Production was between 1912 and 1927, at an average grade of about 66 ounces per ton silver. There was high grading in the 1930s, but not much work since. In all, the district produced about 311,000 silver equivalent ounces. There's been sporadic exploration in the area since the Second World War. Bellehelen is located in the AJAX caldera, one of the largest calderas in the Oligocene ignimbrite flare-up. Bellehelen is one of a string of mining districts and deposits that stretch along the Kawach-Toyabe lineament from the Reveille district to the southeast, where VR Resources is working, through Bellehelen to the Ellendale, Hanapaw, and Midway districts. Enfield Resources is currently exploring in the Ellendale district and was exploring near Hanapaw. The Midway deposits being explored by Viva Gold. So this is a prolific trend, and we're on it. Here's the regional geology. Gardner et al. In 1980 mapped the Kawach caldera using air photo analysis. Largely, they didn't have a lot of time or resources for field work. Identified numerous faults and potential units in the area. Our work in the Bellehelen area suggests that a lot of these aren't in fact there, except this one here, which is definitely a caldera bounding fault. Crawford compiled the county maps. There's a large subvolcanic intrusion here. This area is much higher topographically than here, and this was unroofed. Denise Hahn in 2005 did a lot of mapping in the area. She identified this Bellehelen caldera, one of 5 calderas in the region, dated at 23 million years old. We found her mapping to be quite accurate and reliable, and forms the basis for much of what we've done. Let's take a look at the property geology. We'll start with the claims, and I'll overlay a 2019 precision aeromagnetic field survey on top of this. We'll rotate it 30 degrees just to fit more stuff in. I want to draw your attention to these two areas of relatively low total magnetic field gradient and relatively low total magnetic field response, rimmed by areas of high gradient. As it turns out, these two geophysical anomalies correlate to real geologic features. And here's our mapping. The Bellehelen caldera is this tan unit here that Denise Hahn mapped. The two geophysical magnetic lows are here. This is the Ben-Hur crater and the Merger crater, both within the overall Bellehelen caldera. Within the Ben-Hur crater is a small unit here. This is a lapilli block ash tuff breccia. It is notably coarse on the east end and fines to the west. It may be silicified. It's a resistant unit, and most of the workings in the Ben-Hur mine area are along this feature. It's intruded by a small block of andesite here, shown as a separate unit. There's a structural geology. You can see dips here and here dipping in towards the Ben-Hur crater. The margins of the Bellehelen crater are not so well defined, although you can see dips dipping in here, but there's superimposed on that is kind of an undulating corrugation where the rock units are folded like waves within this unit here. There's an additional unit, this TBX. These are megabreccias or xenoliths, fragments of the older caldera margins which slid in to the caldera. We haven't mapped all of them, but what you see here are a selection that show up in the area we're working. Let's take a look at a cross-section across the Ben-Hur crater to get more idea of what the structure might look like here. We're looking west here on this cross-section line, and you can see that dips are quite shallow on the margins of the crater. Extrapolated, they probably meet down here. The block ash lapilli tuff breccia is a notably steeper dipping unit. It's slightly discordant with respect to some of the other units in the area. It's possibly this might actually be a vent. Nonetheless, it's discordant with respect to the dip of the surrounding units. We don't know what it does at depth. This is a guess. Here's what the rocks look like. The Bellehelen caldera, which is the underlies the majority of the area, consists of lapilli ash or ash lapilli tuff. It's generally quiescent, particularly on dip slopes like you see here. Forms sort of low undulating terrain, largely covered with colluvium. In detail, it looks like this. You'll see a maroon matrix in which are suspended these white pumice-classed fragments. There's about 5% lithics in this rock, generally pretty fine grain. And there's a few fiamme in place, but for the most part, there's an unwelded tuff. The Ben-Hur crater is very similar to the Bellehelen caldera. It contains coarse units. This is a block lapilli ash tuff here. You can see the large blocks in it. This is about as good as you get for bedding anywhere in either the Bellehelen caldera or the Ben-Hur crater. You see here a fine grain ash unit beneath a coarser block lapilli ash tuff. There are ash units, lapilli ash units within the Ben-Hur crater near the top. Here's a hoodoo of lapilli ash preserved beneath a xenolith that slid in from the wall of the crater. Within the Ben-Hur crater is a block lapilli ash tuff, looks like this. Consists of coarse pumice fragments, some of them a foot or more. We've seen ones up to 1 meter in size. There's also football size lithics within this unit. These are chunks of the Paleozoic basement that came up when this unit was in place. This unit finds to the west, but is generally a resistant unit, perhaps silicified, and most of the workings in the area of the Ben-Hur mine are along this unit. They look like this. They're basically on fracture systems that are slightly oblique to the overall strike of the block lapilli ash tuff breccia. Finally, the uppermost unit, not much of it, but mapped in places, is this TBX. It's a megabreccia or xenoliths. These are chunks of the caldera wall, the older rocks, that slid into the crater after eruption. Here's a great example near the hill they call Squaw Tip. You can see there's a flat line xenolith here. The rocks underneath are a lot different, however. They're notably deformed. Here's a view. These rocks must have been just about plastic when that xenolith slid in, and they've been mushed up fairly significantly. To try and understand the geology in this area a little better and unravel some of it, we ran portable XRF or nighttime gun analyses on the rep samples that we collected during geologic mapping. Now, what we did was we analyzed just the pumice fragments because research has shown that that's the best way of discriminating different pyroclastic units. We ran principal component analysis on all of the analysis we collected using the common elements, the ones that showed up in every scan. And the results of this analysis is shown here. PCA factor 1, which explains most of the variation you see in the data, is plotted. And you'll notice that all the higher values for PCA factor 1 are generally clustered in the Ben-Hur crater. And this suggests and confirms our supposition that this is its own rock unit distinct from the overall Bellehelen caldera. We also ran calculated the rubidium-strontium ratio. This is a proxy for the sodium-calcium ratio. Now, in some exploration settings, you can use the sodium-calcium ratio as a proxy for heat flow. Generally, there's more alteration, more sodium over calcium, closer to the heat source. They use this a lot in volcanogenic massive sulfide exploration as the Ishikari alteration index. We tried it here. And since we can't measure sodium and calcium with a pXRF gun, we used rubidium and strontium, their proxies. And what we found is this. You can see here that the higher rubidium strontium, this would correspond to the higher heat flow, is along an axis that runs basically along the center of the caldera. So this suggests to us that this is the true central vent of the Bellehelen caldera and the axis of heat flow, and likely the structure that localizes mineralization in the area. Let's have a look at the alteration mineralogy in the area. We analyze this with a shortwave infrared spectroscopy, and we measured the alteration spectra, analyzed them with the spectral geologist, and here's what we got in the way of alteration mineral assemblages. Now, what I've done here is I've shaded out to light colors any of the muscovite through smectite series. And let's just concentrate on the lower pH, higher temperature minerals shown here. So primary kaolinite through dicite. You'll notice that all of those minerals tend to occur only in and around the Ben-Hur crater. So this suggests to us that this was a locus of high heat flow and relatively acidic, perhaps mineral-bearing fluids. So all in all suggests that the Ben-Hur crater is definitely a good place to go looking. Another thing we did with the data was analyze the crystallization index. Now, what this is the ratio of water to aluminum, or the 1900 to 2200 nanometer absorption spectra. And you can think of the high numbers as an indicator of minerals that are more crystalline and have less water. So these are your hotter minerals. Once again, they tend to be in the area of the Ben-Hur crater. So these are the kinds of minerals, the ones that are shown up in red, that you would expect to see in an area of higher heat flow. These would be the clays that tend more towards muscovite rather than smectites. Those guys are found out over here. So all in all, again, confirmation that the Ben-Hur crater is a good place to go looking. So let's turn to economic mineralization. That's what we're here for. Most of the mineralization in the Bellehelen district that we found to date is low sulfidation, structurally controlled mineralization. It looks a lot like this, generally in fracture zones, rather dry. They might be a half meter to up to 2.5 meters in the merger mine. They don't have a lot of quartz in them. You'll notice there's just a few stringers of quartz you see in some of these shear zones. What quartz you see is chalcedonic, sometimes a little opaline. They're sulfides, generally pyrite. Now, when we looked at this style of mineralization, we were scratching our heads a little bit, didn't fit quite in a Buchanan model, but we found a pretty good analog in the Palmarejo district, the Guadalupe deposit in Mexico, where the rocks overlying a significant low sulfidation deposit were argillically altered and rather tight. And as a result, the fractures that overlaid the deposit were of a nature like you see here, not much quartz, rather tight, in argillically altered rocks. And the argillic alteration formed an aquitard over a larger, quite prolific low sulfidation system. So we think that might be what's going on at Bellehelen, that many of the workings you see here are sort of up on the roof, not having gone deep enough to see the full extent of the mineralization. They've only gone down a couple hundred feet at the merger mine, and that's about the deepest that we know of in the district. So we think there's some potential here to find a larger low sulfidation deposit at depth beneath these numerous workings that you see here, some of which were actually mined on a small scale. There's also a different style of mineralization that we found recently, and I'll show you that towards the end of this presentation. Historic mine workings are a great place to start when looking for mineralization, and Bellehelen's no exception. Most of the workings are clustered in the area of the Ben-Hur mine here, over at the merger mine here, which is not an area we map. There's also workings in this AJAX mine, 2% workings here. And there's subsidiary workings off trend, particularly along this iron hoist shaft trend here. You can see that the workings tend to cluster along that heat axis that I mentioned earlier in the presentation. Let's look at some rock sample results. Now, most of these are graphs, but there are a number of chip samples from the Ben-Hur, iron hoist, and AJAX mine areas as well. We'll start with silver. Bellehelen is a silver camp, and as you can see, there's more than a few high-grade silver analyses came out of our sampling of mostly historic workings, in a few places in situ mineralization, particularly near the AJAX mine. Here are the gold in rock and chip sample results. We found it interesting that the gold endowment in Bellehelen is a little higher than we would have expected. We came in here thinking that this was primarily a silver camp, but there are gold analyses up to 11 grams have come out of many of these workings here, and more than a few over half a gram. So it suggests to us that there's a gold fingerprint in the Bellehelen district, which wasn't recognized by the old timers at a time when silver prices were a lot higher. We've run soil geosurveys on 3 different grids over the last couple of years, and I'd like to show you the results from the AJAX mine BH and QA grids. So here are results at the AJAX grid. In addition to running soil geochem surveys, we also ran horizontal loop EM and toll mags field surveys over this grid. So I've also plotted the HLEM conductors here that might be correlated with bedrock conductors, perhaps vein fault systems. We're starting with silver, and you can see there's high-grade silver results, both in soils and bedrock in the area of the AJAX mine here, and also at what we call the eastern shaft over here. Notably, the highest grade silver results were in the bedrock samples from an exposure distal from the actual shaft where most of the workings were done. Here are the gold results, and the highest gold to date on the Bellehelen property was actually collected from this outcrop here, 11¼ grams from a bedrock sample. As you saw in the silver geochemistry, there are anomalies associated with the AJAX mine and very weak response associated with the eastern shaft, and the geochemistry, which could be suppressed by colluvium in the center, but also the geophysics, don't tend to support the idea that there's one big structure linking these two. Heading further south, we put a soil grid over the Ben-Hur mine and its associated showings. They're located down here on this grid. And we're looking at the soil response in silver, which interesting, but nothing to write home to mom about. But the response in gold we find much more interesting. We don't see a coordinated response in the area of the historic workings down here, although there's a few spot highs. There might be something a little more substantial up here. And we're quite interested in finding out what the source of this very high response here, 3.5 grams in soil, up at the east end of the grid might be. If we put the geology on top of it, you can see that there's not a really strong gold response along the trend that the old-timers were working in numerous shafts and adits along here. There is, however, once again, something to the north here, perhaps an antithetic structure. Zooming into the area of that 3.5 gram sample, we can't really figure out what the source might be. It doesn't appear to be anything in the way of historic workings here. Here's where the soil sample was collected. There's a 0.7 gram in soil sample collected here and a 0.38 gram in soil sample collected over here. So there appears to be something more here than just a narrow little vein. So this is an area we want to have another look at next year. In 2021, at the north end of the property, we found a completely different style of gold-silver mineralization. Here, we found that gold and silver had blown out into a permissible volcaniclastic layer along permeable tuffs and on fracture zones. It's in an area of very poor exposure. There's only 2 outcrops, basically a small knob of quartz adularia down here, and then a shaft up here with some pyritized tufaceous rocks. You're looking here at the response of gold in soil. There's some, nothing to write home to mom about. More encouraging might be the response of mercury. This is what this mineralization looks like. We're going to have a look at that knob of quartz adularia here. And this is the material that was running 0.622. just quartz adularia flooded tuffs. It's in a region of colluvial cover. There's virtually no outcrop. We're flying north along that soil grid right now towards where the shaft was with the 747 sample. So this is a completely different style of mineralization. Looks analogous to us like something you'd see at Round Mountain or in the Silicon project down near Beatty. So we think there's more than meets the eye here at Bellehelen. The historic workings are shallow, and we think largely in a argillized lithocap, perhaps on top of a more prolific low sulfidation system beneath. There is gold and silver in the shafts and adits above, hosted in thin, tight fractures, but we don't think that they represent all that's here. They might be leakage from a larger system beneath. And in addition, there's a different style of mineralization. On the margins of the caldera, we're seeing disseminated gold and silver blown out in permissible pyroclastic units. As I said earlier, analogous to something you might see at Round Mountain or down in Beatty at the Silicon project. So that's it. This spring, we're heading back to Bellehelen. We're going to extend the BH soil grid in both directions to cover off that open-ended golden soil anomaly. And we're going to try and see if we can figure out what's going on at that very high gold response on the east end of the grid, do some hand trenching, see if we can find a bedrock source. We're going to do the same up at the QA grid to investigate the potential for a larger, low-grade gold resource up in that neck of the woods. So stay tuned.